everyone, I Dr. Smita Selat welcome you all once again to the unsupervised machine learning algorithm video lecture. We have been talking about the machine learning algorithm in the previous lecture. So, this lecture will focus basically on way the unsupervised machine learning algorithm work and what are different classes of unsupervised machine learning algorithm, with the major focus on clustering techniques. So, in this lecture we will cover the basic concept, the different types of unsupervised learning, how this unsupervised machine learning is different from the supervised machine learning algorithm, what is cluster analysis, what are various unsupervised machine learning algorithm and the applications, and finally we will sum up. So, talking about unsupervised machine learning, in the last lecture we had talked about the supervised machine learning algorithm, where we focused on the models where input and output data was needed. The very different thing about unsupervised learning is it does not require the supervision to train the model, meaning models by itself tries to find out the hidden patterns or the insights which are present in the input data. As compared to the learning which takes place in humans. So, this is analogous to the way our human brain thinks. So, we can define it as the unsupervised learning as a type of a machine learning in which models are trained using unlabeled data set and they are allowed to act on the data without any supervision. So, unsupervised learning cannot be directly applied to regression or classification problem, because unlike supervised learning we have the input data, but there is no corresponding output data or label attached with the data. So, the goal of the unsupervised learning is to find the hidden patterns or the hidden structure from the data set given the data, that is given the input, without any label, without any output. So, it uses the similarities between the data to create a class or to create a group. The significant features of this class of algorithm is it is very helpful to mine the meaningful insight from the data. We have the collection of data and these algorithms are very helpful in finding out the relationship or finding out the patterns in the data. And it works like a human brain. That means how we as a human, we try to use our experiences to identify which data items are similar or which data items are not similar. Since it works on an unlabeled or uncategorized data, it is more applicable to the real time problem, and this is the point, or this is the main feature why it is known as unsupervised. Actually, in the real world also, we do not always get input along with the output values, meaning we never get, it is very difficult to create the labeled data. So, real time data is the only input data we have. So, unsupervised machine learning algorithm are more applicable to the real time scenario. Example is, let us take with the help of an example. We have an unlabeled data which is an input data. What the model will do? Model will try to interpret or will try to draw the insight from this raw data, and it will try to find out what are the patterns which are hidden in the data set. Then suitable algorithm like k-means clustering or the other clustering algorithm or decision trees are used. Specifically, the clustering algorithms are used and they are applied to the data. Then what does this algorithm or these algorithms do? What they divide the data into groups or they divide the data into classes, and the logic behind this division is similarity in the data set. Whichever data points are similar will fall in one group and which are not similar will fall in another group. As it can be seen in the diagram, where we see a picture of dogs and cats, the features are extracted and the model is built. Since there is no label given to the data, the unsupervised machine learning algorithm or the cluster algorithm will analyze these features, and based on similarity and dissimilarity parameters, it will divide each of these elements into different groups. As here in the example, dogs will be identified and it will be placed in the dog group. Similarly, animals which look like cat will be placed in the cat group. There are various types of unsupervised machine learning algorithm, but popularly two, clustering and associations, are the two popular techniques which are available in the unsupervised category. Let us try to understand clustering. As clustering is more popular unsupervised machine learning algorithm, what does clustering do? As discussed in the previous example, these are the methods which group the objects into groups or the clusters. These clusters will contain data points which are similar to each other, and the data points which are not similar will be placed in the another group. So, major objective in creating a cluster is to find out what points or what common parameter exist amongst the data point. Based on these common points, the data are categorized or classified or grouped into different groups. So, we identify the clustering as a presence or absence of commonalities amongst the data points. In short, similar data points are placed in one group or the one cluster, and points which are dissimilar to this are placed in another cluster. Likewise, another type of unsupervised learning is association. What does association do? Association is an unsupervised learning which is used to find out the association or relationship between the variables. There are certain variables which are highly correlated, or their occurrence together matters a lot. For example, whenever the business houses they make a marketing strategy, then this concept is widely used. For example, whenever a customer they go to a shop for buying an item, let us say in a supermarket, obviously a person who is buying a bread will also buy butter or a jam, indicating the butter and the bread are correlated or highly associated with each other. So, in that supermarket, these two items will be placed together in the same shelf. So, association concepts are basically used in business houses to find out which parameters are related to each other. But in this video lecture, we will focus more on the clustering techniques. Clustering and association is very well depicted in the diagram given. As we see in the diagram, in the clustering, all the data points are given to the algorithm, and then algorithm identifies them into different groups as it is indicated in different colors. Whereas, association rules will try to find out which items are associated or correlated or related with each other. As we have seen, the unsupervised machine learning algorithm does not require any label data. Hence, it becomes more difficult to find the patterns or more difficult to find the clusters. But advantage of unsupervised machine learning algorithm is कि in a real time scenario, it is very difficult to get a label data or input output pair of data for creating a model or for solving a problem. So, it is very easy to get unlabeled data as compared to the labeled data. Hence, it is more easy to apply unsupervised machine learning algorithm into a data set. against the supervised machine learning algorithm where the label data was required. So, this is one advantage. Another advantage is that this is more applicable on the more complex task as compared to the supervised machine learning algorithm, because these techniques, they themselves are trying to find out which items are closer together, which items are associated with each other. So, because the load is on the algorithm, not on the input technique, hence it is more easy to apply on the complex task. However, disadvantage of unsupervised machine learning algorithm is that because we do not have an output, hence it is very difficult to obtain a higher accuracy rate in the case of unsupervised machine learning algorithm. Like in the supervised, we had the output label, so it was easy to find out the difference between the actual output and the predicted output, and based on the difference an action could have been taken to improve the algorithm. But here, in the absence of an output data or the label data, the accuracy is little bit compromised. The result of the unsupervised machine learning algorithm hence may be less accurate as compared to the supervised one. Let us now try to compare the two popular techniques in the machine learning, supervised and unsupervised. As we can see, the goal of both the algorithm, in the case of supervised, the goal of the algorithm is to train the model so that it can predict the output when the new data is given. Whereas, in the case of unsupervised algorithm, the goal of this algorithm is to find the hidden patterns, is to find the association and draw the meaningful insight from the given data set. Next is labeled and unlabeled data. As discussed, the supervised machine learning algorithm uses labeled data. That means, we are giving the combination of input and output variable both to the model when the model is being trained, and even the case of test phase, we are giving both input and output. Hence, we have a labeled data in the case of supervised machine learning algorithm. Whereas, in the case of unsupervised, we did not require any label, only input data is given. Next point of difference is, in the supervised, we take a feedback, and what is that feedback? The difference between the predicted and the actual output. We have a cost function, we have the error function, and the algorithm, they try to minimize this error function. In the case of unsupervised machine learning, there is no explicit feedback mechanism which exists. Another point of difference is, supervised machine learning model, it will predict the output. Major task is to predict the class or to predict the value. Unsupervised machine learning model finds the hidden pattern. So, here is a job of a prediction, where here it is a task of finding the hidden patterns in the data. Then what are different categories which exist in the supervised machine learning algorithm? Two major categories is classification and regression. Classification works for the categorical data and regression for the continuous data. In contrast, the unsupervised learning can be classified as clustering and association, where clustering objective is to find the clusters and in association is to find the relationship. More accurate result is obtained in the case of supervised machine learning algorithm, and unsupervised machine learning algorithm, we do not get that accurate results. Examples of supervised learning is logistic regression, linear regression, support vector machine, decision tree, etc. In the case of unsupervised machine learning algorithm, clustering algorithms like k nearest neighborhood, the a priori algorithm, DB scan algorithm, and so on. So, let us first try to understand what are cluster. As discussed, the clustering technique is analogous to the way we humans think, and the arrangement of similar object is actually captured during the analysis process. Let us say when a child learns any new concept or human brain when learns a new concept, whether it is learning which picture is of a cat or which picture is of a dog, the human brain tries to identify or it tries to pick up a data which are similar to each other and tries to create a group or a cluster, and then this human brain tries to learn the concept of a car, a dog or a trees. In a similar fashion, the cluster analysis will analyze the data to find out which data objects are similar to each other and create a grouping mechanism, which is analogous to the human brain working. And this exactly is the point which explain why cluster analysis is often considered as a branch of pattern recognition. Like human brain tries to recognize a pattern, similarly clusters will try to analyze the data point, finding the similarities between them. The cluster comes under the unsupervised machine learning algorithm, and it is applied to the data set where patterns, we want to discover the patterns in the data set or we want to group the data items. No prior knowledge or no additional knowledge is given to the system. It is sensitive to the similarity or dissimilarity measures amongst the data point. So, clustering analysis, no doubt it is a machine learning technique. Let us define it formally. So, what is clustering? It is a way of grouping the data points into different cluster consisting of similar data points. The objects with possible similarities remain in one group and the one which has less or no similarities with another group. It finds some similar patterns in the unlabeled data set. That similar pattern may be the shape, the size, the color, behavior, and divides them as per the presence and absence of those similar patterns. After applying the clustering technique, each cluster or group is provided with a cluster ID. Machine learning system can use this ID to simplify the processing of large and very complex data set. We should note that clustering is somewhat similar to classification algorithm, but difference is the type of the data set which we are using. In supervised classification technique, the labeled data set was used, whereas the clustering technique uses unlabeled data. Let us try to understand the cluster with the help of an example. 14 objects are taken, their heights and weights are measured, and then we plot the height and the weight of these 14 objects into two-dimensional space, x axis taking the height and y axis taking the weight. These 14 data points can be divided into two groups as it is seen in the graph. Weight parameter is more spread out as it is visible in the figure. Objects with the weights, with the larger weights, that is ranging from 3 to 6, they lie in one group, and the objects which have the smaller weights will lie in another cluster. This classification is very obvious in the figure which is shown over here. Two parameters, height and weight, are used to create the cluster. The one objects which are lightly weight, which have less height is having less weight. Objects which are having higher height is having a more weight. There are various applications of clustering algorithm. To name a few, market segmentation, statistical data analysis, social network analysis. Like in the social media, at times business houses are very much interested in knowing what segment of the customer is liking their product. Let us say if it is a bookstore or a bookstore where the books are being sold to different customer, there might be a segment of the user who are more interested in classical novels, and there might be segment of users who might be interested in reading the fiction stories. So, classifying the user based on their interest is exactly where clustering can be applied. Another very important application is recommendation engine, documentation clustering, where multiple documents are there, the major objective or topic of a document may be different, identifying what that particular document is for and clustering the similar documents into one group. Likewise, recommendation engine recommends various product to the user who have a similar interest. The user having a similar interest are clustered together, and whenever they search the search engines for a product, the similar type of related products are shown to them. So, these are some of the very common applications which use clustering technique. We have seen in our real time applications the companies like Amazon and Netflix, they are using recommendation system in their application, which is an AI based system to identify the users which are having a similar interest, or to just show them the recommended product which they may like. Once they have seen a product which and they are interested in a product, a similar related products are shown to them. The below diagram explains the working of clustering algorithm. We can see how the different fruits are divided into several clusters or groups together. If you remember, we had taken the similar example when we were discussing supervised machine learning classification algorithm, and the same example we are taking it over here. But the aspect is now this is a clustering task, as we do not have a label data set. We have got a mixture of fruits, then their properties is extracted. These features or properties are given to the machine learning unsupervised algorithm. What this algorithm does is tries to find the hidden patterns. Using features, it will try to group the data items such that the similar data items will fall in one group. For example, we can see the apple, because they will have the same features, it will fall into one group, likewise the other fruits. So, the same problem, but the technique to use to solve them is different, because data set is different. So, various clustering techniques exist. Some of the clustering techniques are hard in nature and some are soft. What do we mean when we say it is hard? Hard means data point will belong to only one group. If we have a data points in an n-dimensional space, then if we are applying a hard clustering technique, then if we pick up a data point, that data point will belong to only one cluster. Whereas, in the case of soft clustering, data points can belong to another group also. So, participation of one point, if it is only in one group, then it is hard, otherwise it is soft. Some of the popular clustering techniques are partitioning clustering, density based clustering, distribution model based clustering and hierarchical clustering. Let us try to understand each one of these clusterings one by one. Partitioning clustering is a type of a clustering that divides the data into non-hierarchical groups. This method is also known as centroid based method, and one of the very popular technique which is used in this is k-means clustering algorithm. What happens in this? The data set is divided into k groups. That means we should know the value of k in advance. If we say value of k is 3, then our objective will be to divide the data into 3 different groups. So, k defines the number of groups or number of cluster. The cluster center, that is a center data point, is created in such a way that the distance between the data points of one cluster is minimum as compared to the another cluster centroid, meaning data points in one cluster should be very closely associated, should be very close to each other in terms of distance, and those points which are in another cluster should be very much far away from this cluster data points. Another is density based cluster. So, density based cluster basically focuses on how closely or how densely the data points occur together in the data set. The main key feature in the density based clustering is it allows arbitrary boundary of a cluster. Instead of having a geometrical boundary, it can have any arbitrary boundary of the cluster. And this particular algorithm can face difficulty in clustering the data points if the data set is having diverse dimension and varying density. Next is distribution based model, where the data distribution is taken into consideration for creating a cluster. One of the very popular distribution is Gaussian distribution. We also call it as a normal distribution. How the data is varying or how the data is distributed, that parameter is taken for creating the groups. One of the popular algorithm under this category is expectation maximization clustering algorithm, which uses Gaussian mixture models. Another class of clustering is hierarchical clustering, and this is one of the very popular clustering algorithm, because it does not require the number of clusters or the information of number of clusters in advance. Here the data items are grouped together and a hierarchy is created as shown in the diagram, and that diagram which represents this hierarchical clustering is known as dendrogram, and one of the very popular algorithm is agglomerative hierarchical algorithm, which we will see in short. So, important parameter in clustering algorithm is distance metric. Distance is a very important parameter, because whenever we are creating cluster or a group, what is the distance between the data points? This needs to be measured. Similar objects in one cluster, dissimilar objects in another cluster. So, intra-cluster dissimilarity should be high. That means, distance between the two clusters should be more, and data points which are within the one cluster should be less. So, which distance metric is used to calculate the distance? Two common metrics, two common measurements, Euclidean distance and Manhattan distance. So, what is Euclidean distance? As can be seen with the formula, if we have the 2 points in the two dimensional space, we calculate the difference between the data points, take the square and the square root, that will give you the Euclidean distance. It is actually the measure of the hypotenuse of a right angle triangle as per the mathematical concept, and it is very popular used distance metric in cluster analysis. Another parameter is Manhattan distance, where we take an absolute value of the difference between the two data points. Depending upon application, we can either use Euclidean distance or Manhattan distance. Before we can give this data for unsupervised machine learning algorithm, we must prepare the data. Data, when it is captured, is very raw in nature, and there are a lot of variation in the data. So, data pre-processing technique is very important aspect, and it must be applied to the data before the data is fed into the machine learning algorithm. Here in this video lecture, I will only talk of two very important data pre-processing techniques, but there are various techniques which are used to fine tune the data set. One of the important technique is standardizing our data, because the range of the data at times may vary a lot. So, standardization means that every value is subtracted by the mean value of the data, and then it is divided by the standard deviation, and this creates a standard data. It scales down the data, and we get a defined range of a data. So, even if we have a minimum to maximum value or data is dispersed widely dispersed, then this technique is used to bring down the data into a defined parameters. It is also known as a Z-score method. Another important pre-processing technique is how do we handle the missing values. Whenever the data is collected, there are certain values which are missing or not available. So, how to handle them? We generally use the statistical parameters like mean, median and mode to replace the null values with the actual values or with the mean, median or mode values. So, statistical parameters or techniques are applied. Coming back to what is k-means clustering, one of the very popular algorithm as discussed. In this algorithm, we must know the value of k. K stands for number of clusters. This number of clusters should be defined. It can be 2, 3 or 4, and once it is known, then we can create a cluster. And every time we take a mean of the cluster to define the center of the cluster. There are various variation of this k-means algorithm, mini batch k-means or k-mediots. The basic k-means procedure can be described as follows. First, decide on the value of the k, randomly pick up k points from the data sets, assign other data points to the nearest cluster by calculating the distances, take the mean of the data points and make this as a new cluster center. Repeat these process step number 3 and 4 until we no more data is left or we have obtained a minimum distance. Two parameters are important in k-means clustering, the initial value of k and the k data points we randomly choose to define the clustering. These two parameters they make a lot of impact in how our clustering algorithm works. This is a sample data set which shows how the different values of k are used to create the cluster. K is equal to 3 and probably k is equal to 5. Another important clustering algorithm is density based, and it is known as DB scan clustering, where density is taken into consideration. The density, whenever we talk about the density, then 2 points are important. How much minimum number of points are essential to define a cluster, and another is a very small epsilon value which will control the density parameter. Density means very closely related, very closed data points will be placed into one cluster, and that closeness is defined with the value of epsilon. Some of the very positive parts of DB scan clustering algorithm is, if we have outliers, then the algorithm is not affected by them, and very few and straightforward parameters are needed in DB scan, and the natural extension, it is a natural extension of distance metric. Some of the drawbacks is very difficult to decide upon that epsilon parameter which will be basically responsible for creating the cluster. As we can see, the DB scan is different than the other algorithms, as we see the noise, if the noise is present in the data, then k-means cluster will not be able to work as good as the DB scan. Three figures are shown. The figure on the right is a classification, or we can say clustering, DB scan clustering algorithm, which handles the noise given in the purple color very nicely, and it creates a very defined clusters even if the noise is present in the data set. So, that is also a very plus point of DB scan. So, let us see how it works. It picks up a random point and starts a process and looks within epsilon distance of that point to find the other points. If no such points are found, then we go back to the step 1. When another point is found within the epsilon distance, we designate this a cluster and repeat the steps 2 and 3. And this process will stop when each point has been visited and a cluster has been decided. We can see the impact of DB scan on the different values of epsilon, on the different values of minimum count, that is a minimum number of clusters. Another clustering is agglomerative clustering. It comes under the hierarchical category. The basic idea of agglomerative clustering is very simple. The algorithm itself will look around in a very natural way to find the points which are similar to each other. It is also known as greedy algorithm. The four major steps of the algorithm are: we first describe the distance between the two clusters and call it as intercluster distance. Make each point, we start with by making each point as its own cluster. Find the two clusters with the smallest distance between them and merge them into a single cluster. And this process is repeated until we get a substantial number of clusters and every point has been visited or traversed. Here in agglomerative clustering, at each iteration or the loop, we need to calculate the distance between the cluster and the rest of the remaining points. This becomes a drawback because it is a very expensive operation. The amount time complexity goes in the order of n to the power 3 and the memory requirement in the order of n to the power 2, which makes it very difficult to use for a very large data set. And there is also issue as to how exactly we describe a distance between the two clusters, that is the intercluster distance. Agglomerative clustering uses 3 points: single link distance, the complete link distance and the group average distance. These distance parameters are generally used to find out how closest the 2 points are. The single link distance is a distance between the two closest points in the cluster A and B. Complete link distance is the distance between the two furthest points in the cluster A and B. And group average distance is average of distances between the points in the cluster A and points in the cluster B. These parameters are used in agglomerative clustering to work or reduce down the time complexity. So, in this video lecture, we had talked about the unsupervised machine learning algorithm, the cluster analysis, the different types of clustering algorithm, majorly the k-means clustering and the dB scan clustering and hierarchical clustering. I hope you enjoyed the lecture. Thank you.